All right, let's find an exact value of tangent of 2 pi over 3 plus pi over 4. So in thinking about this problem, I notice we have two things that are added together, two angles added together on the inside of a tangent. That's pointing me towards the sum identity for tangent function. So I went ahead and brought that along over here on the right-hand side. As we get filling in, what I would suggest first is just kind of identify where everything sort of fits together. We have two angles that are added together. So I'm going to label this one as alpha, this one as beta. And then as we're trying to figure out uh, adding these together, let's go ahead and just kind of fill into our formula where we can say this is the tangent of alpha, we said was 2 pi over 3, plus the tangent of beta, well, beta we said was pi over 4, all over 1 minus the tangent of, again, alpha is 2 pi over 3, times the tangent of beta, which is pi over 4. All right, so really just use my formula, filled in the appropriate spots for alpha and for beta. From here, we would like to evaluate this. Now, pi over 4, that's one of those angles that's pretty nice, and evaluating this should be pretty easy. That tangent of pi over 4 is just going to give us a 1. However, the tangent of 2 pi over 3 is a little bit more complicated. So off to the side here, what I'm going to suggest is let's see if we can evaluate just a little bit of side work here. I want to evaluate the tangent of 2 pi over 3 as side work over here, but I don't know what tangent of 2 pi over 3 is off the top of my head. So instead, what I would probably do is place this in the appropriate quadrant. So 2 pi over 3, I guess that's bigger than half of a pi and smaller than 1 pi. So this is going to fit into the second quadrant. So 2 pi over 3 wraps around, give or take, right about there. From there, what I would next do is identify the reference angle, which can be drawn to the x-axis. And this reference angle, let's just call it theta bar. So theta bar, the calculation there would be the far side of this angle, identified in red here. The further side is going to be pi, minus the shorter side was 2 pi over 3. So to calculate this reference angle, theta bar, I would maybe think 3 pi over 3 minus 2 pi over 3. Well, it's going to be pi over 3. All right, so I would like to fill in, plug in, substitute in pi over 3, this reference angle, into our tangent function in place of the 2 pi over 3. However, this is the place where we need to be very, very careful. Whenever you want to substitute in a reference angle, like I'm trying to do right here, you have to double check and say to yourself, is that going to be positive or negative based on the 2 pi over 3? So 2 pi over 3, as we drew it in, was in the second quadrant. This phrase, all students take calculus, is always very helpful for me whenever I'm thinking about this. 2 pi over 3 was in the second quadrant because all students take calculus. Sine is the only thing that's positive in the second quadrant. It's just based on the first letter in each one of those words. Everything's positive in the first quadrant, only sine is positive in the second quadrant, tangent in the third quadrant, and cosine is positive in the fourth quadrant. But we're dealing with tangent, and our angle is in the second quadrant because sine's the only trig function that's going to be positive in the second quadrant. We need to be especially careful to put a negative out in front of the tangent of pi over 3 as we plugged in that reference angle. Now, as far as evaluating this goes, we'll bring along that negative that we just placed out in front, and the tangent of pi over 3 is just going to be the square root of 3. Hopefully we know that, or we have a chart handy to evaluate pi over 6, pi over 4, and pi over 3. All right, so what we can do at this point is let's go back over to our formula on the right-hand side and think about plugging everything in. So we just said with our side work that tangent of 2 pi over 3 could be replaced with negative square root of 3 plus the tangent of pi over 4 we said was 1 over 1 minus, again, tangent of 2 pi over 3 can be replaced with negative square root of 3 times tangent of pi over 4. Well, tangent of pi over 4 is going to be 1. So the other cleaning up and making this look a little bit nicer, maybe we say negative square root of 3 plus 1. You could transpose those, write them in the other order. And then for our denominator, we could say 1, and then this double negative makes an addition for the square root of 3, and then times 1, I'm just kind of dropping the multiplying by 1. So that's a pretty good answer. The only thing that we could use to make this making a little bit nicer is we still have a radical in our denominator. Lots of the homework systems do accept it just like this with a radical in our denominator. But mathematically speaking, we can make this a little bit nicer if we multiply by the conjugate for our denominator. That will eliminate the radical from our denominator. We say that's rationalizing the denominator. So what we could do is we can multiply by the conjugate of 1 plus the square root of 3 is just going to be 1 minus the square root of 3. But if we want to do it in the denominator, we also have to do it in the numerator. So multiply both of them by 1 minus the square root of 3. Now, I'm just going to take my time and multiply this out. So go first, outer, inner, last. In this case, I'm going to get negative square root of 3. Outer is going to be a plus 3. Inner is going to be a plus 1. And then last, we get minus square root of 3 for our numerator. Denominator, pretty similar. And I'm going through this kind of quickly, I get, but you've done first, outer, inner, last before. So we have first, outer, inner, last. Get maybe just slightly better answers by combining together like radicals and like terms as we go. All right, so in our numerator here, we can definitely say 3 plus 1 makes 4. And then we also have like radicals. We have a negative square root of 3 minus another square root of 3. So that's minus 2 square root of 3's. And for our denominator, well, we can say 1 minus 3 makes negative 2. But then these are like terms, or like radicals. So we have a positive square root of 3, and we're subtracting away a square root of 3 as well. These get to simplify down and make 0 square root of 3's, or some people say cancel out. All right, last thing I'm going to go ahead and do is, I notice a bunch of 2's or multiples of 2 going on here. I'm going to split this apart into 2 separate little fractions. We right now have one big fraction. I'm going to rewrite this as 4 over negative 2. Bring along that subtraction from our numerator, 2 square root of 3, all over that common denominator of negative 2. And then some final simplifying down here. 4 divided by negative 2 makes negative 2. I'm going to think these double negatives make an addition, right? Negative and another negative is going to make a positive. These 2's, one in the numerator, one in the denominator, is going to make a 1, or some people would say cancel out. And we're still going to have a square root of 3 as part of our overall final solution. This is the best solution we can get to in this situation. So I know it took up a whole page. There's quite a bit going on with reference angles and everything else, but be careful as you go through these. Identify alpha, identify beta, have your formulas handy as you're getting them memorized, fill in appropriately into the formula, because if you mess that step up, the whole rest of the thing is going to go a little bit wrong. So take your time, one step at a time, you'll get there. Good luck.